evaluate this double integral on R, where R is the parallelogram joining the points, by making an appropriate change of variables. So when we locate these points, here is 1, 2 and 3, 4, 4, 3 and 5, 6, 5. Okay, we have a parallelogram. Now this region is not good, okay, it's complicated. So we want to make some change of variables, then this region will be transformed into a nicer region. Okay, we need to make an appropriate change of variables. For that, let's find the equations of these 4 lines, okay, and we might get an idea from there. And looking at the integrand, we have x minus y, so we'll make x minus y equals u. Then we need to find something for v. This is in xy plane, xy, so we want to change into uv, and the shape hopefully will be much nicer than this. Okay, let's find the equation of this line first. Okay, I want to find here. So for this one, slope is just rise 4 minus 2 over run 3 minus 1. So slope is 1. So is the slope of this line. Okay, I mean this should be the same because these two lines are parallel. Slope is 1, so y equals 1x plus b. To determine the value of b, we use one of these points, 1, 2 or 3, 4. Let's use 1, 2. So 2 equals 1 plus b, subtract 1 from both sides, b equals 1. So the equation of this line is y equals 1x, so x plus 1. Okay, let's not box this. And I want to write somehow, looking at the integrand, I got idea of writing x minus y. So how about making x minus y? Move y to the other side, subtract y, subtract 1. So we get x minus y equals negative 1. Okay, in the same way, let's find the equation of this same slope. So y equals mx plus b. Let's use point 4, 3. So 3 equals 4 plus b. So b equals negative 1. So the equation is y equals m1x plus b. b is negative 1. So we're going to write x minus y. So move this over. So x minus y equals 1. So when we make substitution x minus y as u, so this becomes u equals negative 1, just a vertical line, and u equals 1, another vertical line. So we are getting better shape. Now let's work on these other sides, the equation of this line and this line. Okay, for this, let me work here. Let's find the slope. Rise over run, 3 minus 2, 1 over 4 minus 1, 3, 1/3. Y equals mx plus b. This goes from 1 to, so 2 equals 1/3 times 1 plus b. Subtract, we get b equals 5/3. That means the equation of this line is y equals mx plus 5/3. Let me write in the same way like we found these two. Okay, multiply through by 3, we get 3y equals x plus 5. How about subtracting 5 and 3y and 5? So this is same as x minus 3y equals negative 5. So we are getting another substitution here. Okay, previously this is u. Now I'm gonna make x minus 3y is v. So we have to find equation of this line, which will have the same slope like this, 1/3. So So y equals 1/3 x plus b, and the top line here passes through 3 4 or 6 6 5. 3 4 doesn't matter which one we use. 3 4, so 4 equals 1/3 times 3 plus b. 3 cancel, 4 minus 1, b equals 3. Okay, that means y equals 1/3 x plus b is plus 3, multiply through by 3, 3y equals x plus 9, which is same as x minus 3y equals -9. Okay, that's the equation of top line here, this, and x minus 3y is v, so this is also v. So this is how we make appropriate change of variables. So let me go up and write this down here. Now we can say, okay, these are all, let me erase these. So we found all the equations, by the way, and let's say here, let u be x minus y and b be just x minus 3y. Okay, with these, our new graph in UV plane will be, let me draw over here, UV. I'm getting negative, so I'm putting a lot on the lower part. U, this is V, so U equals -1. So this is U, -1 here, let's say here. Okay, a vertical line, U equals -1 and U equals 1. Another vertical line here, then V equals -5. So this is 0, 1, 2, 3, 4, 5. Okay, I have not scaled this, but let's say this is -5. We don't have to have exact anyways. This is, okay, V equals -5 and V equals -9 somewhere. Okay, V equals -5, V equals -9. This is U. So we got a nice reason. In fact, this is a rectangle, and we know how to do a double integral on the rectangle. We don't have to worry about finding type 1 or type 2. So U is going from -1 to 1. Okay, U is here, -1 to 1, and V is here, you can say -9 to 5, because the smaller comes first. Now we need to compare the area of this rectangle with the area of this parallelogram. We need to find Jacobian here. Okay, we need to find Jacobian of UB. That means we are converting, so let me not write this. So we need this in that formula when we are making change of variables. dxy, xy's are being changed into uv. So we need to find this. Unfortunately, we found here u equals v equals. Okay, we can solve these two linear equations in terms of x and y, then find this, or instead of this, let's find its reciprocal. We are supposed to find this, but let's find this, duv with respect to xy. Then when we take the reciprocal, we get the correct Jacobian. That is partial of u with respect to x, y with respect to x. So partial derivative with respect to x is 1, -1, 1, -3, -3 minus 1 plus 1, so -2. So we needed the following. We are changing xy into uv, which is in fact reciprocal of this -1/2. That means this new area is twice as much as the original, so we need to cut by 1/2. When we write down double integral, we take absolute value. Now finally will be done in a couple of lines. It was given in the question, there was that was our parallelogram. X minus y dy dx or dA, same thing. This is same as we got new region here, let's say D or any other names, and x minus y is our u. That's what we got the idea, u, and dy dx or dx dy doesn't matter in our case. Area, let's write now dA. In the next, this is easy because we have a rectangle, so we can write du dv or dv du, doesn't matter, and our integrand is u. Okay, v, this is the outer, v equals, we already decided, -9 to -5, and u equals -1 to 1. Now it's pretty easy. Inside -9 to -5, entire derivative of u is square over 2, and we go from -1 to 1. Yeah, we could have done dv du as well, then just we need to put correct limits. And dv, so upper limit minus lower limit, this 1/2 can be pulled all the way outside if you like, but -9 to -5, upper limit 1 square 1/2 minus lower limit -1 squared, also 1/2, it's 0. Okay, I'm getting 0. Sorry, I forgot to write something. When we convert into new, here we need to multiply by the absolute value of Jacobian. I mean, that is not going to change our answer. Absolute value of -1/2, which is just 1/2. 1/2 I want to put outside, 1/2. Now upper limit, lower limit, it's kind of 0, 1/2 outside, 0. So the final answer is 0. Okay, final.